On February 7, 2017, this spillway at Oroville Dam began tearing itself apart. The catastrophic failure forced the uplift pressure must have started right here at joint 5.
Got it. I've documented the separation. We need to measure the depth.
The head cutting is advancing too fast. Target the center channel and drop the load now.
This reinforcement density is significantly higher than the original specs.
Yes, especially the no 8 and no 9 spacing.
We have to get these anchors drilled before the deadline.
Bay 2 is clear. Send in the tanker. Confirmed. I'm updating the manifest now. We need that crane boom unloaded next.
The camera moves to a medium-wide shot of the on-site concrete batch plant that Kiewit established at the Oral Spillway site.
Crew, call attention to the demolition fragments and maintain safe distances. With the heat rising above 95, ensure you are hydrating every hour.
Spitzens. The chute is visible as a wide, raw rock and earth excavation on the hillside, with none of the original concrete remaining in the...
Keep the flow steady on this side.
All right, bringing the vibrator through now. Watch the elevation right here. Alignment looks good on the center line. Slope is exactly where we need it at 0.5%. All right, keep the trucks moving. We need that next lift poured before the shift changes. Hold it right there. A little more to the east. Perfect, set it.
A transcription captures the essential spoken instructions of the foreman directing the pour operation, along with the interaction.
Temperature check confirms compliance, 75 degrees.
The flow front is perfect. No segregation around the bars.
All right, bring the broom across right there. Easy now. Looks good, boss. We made it.
The drill rig visible in this scene is a Soilmec SR65 hydraulic rotary drill rig.
Carson Plate by construction expansion plane say pilot high yard slide trees a liberty BRC on the Twitter trucks.
The camera closes Chapter 2 with a wide-angle shot showing the emergency spillway hardening works at approximately 90.
The Phase 2 final design reconstruction that would demolish all of the Phase 1 temporary concrete work and replace it with the fully engineered final spillway structure.
The Bidwell 3600 is a self-propelled screeding machine that runs on longitudinal rail tracks. It's The camera moves to a medium close shot of the energy dissipation basin reconstruction, showing the assembly of the new stilling.
Mixer convoy, proceed to upper deck. Haulers, hold short, wait for clearance. Copy that, standing by.
The differential is 55 degrees, exceeding the specification maximum for crack risk.
Direct the crew to increase.
How's that look, Inspector? It's solid. We're clear to set the filler.
How's the alignment on this section?
Looks good. We are clear to tighten the wedges. Okay, bring it up slowly. Alignment is good. Lock it in. We're sending up section 3.
We verified the flush requirement on these upper joints. This one, however, needs attention. Mark joint 103 for follow-up sealant.
Gate is fully closed, pressure holding steady.
Verified. No issues on the seal.
Seal is clear, good to go.
The partial gate and opening test in January 2019 admitted a controlled low flow of 8,300 cubic.
The flow pattern looks excellent at 8,000 CFS here.
The photos are confirming the uniformity across the chute. The camera closes Chapter 3 with a wide-angle overhead drone shot of the spillway, operating at 25,000 cubic feet per second.
Surface texture looks solid here. No deterioration.
Same on this side. The joint sealants are holding tight. Log it as satisfactory.
Make sure the depth is accurate for this run.
30 inches confirmed. Ready for transport.
Showing the application of a penetrating silane silent sealer to the full surface of the main spillway chute to reduce.
The piezometer readings are holding steady at 0.3 feet, well below the 5-foot threshold.
Agreed.
The camera moves to a wide-angle shot of the Oroville Dam itself, the 770-foot earth-fill embankment structure that the spillway serves.
The upgraded system provides a much faster detection to warning timeline. This allows for earlier and more geographic.
This depth reading aligns with the Phase 2 report.
Yes, and the documentation confirms the specified sealant type and installation date.
This assessment represents the formal regulatory closure of the emergency that began in 2017. The rebuilt Oroville spill.
This station, one of 4 on the spillway, recorded the 2.3 magnitude event. The data confirms it was well.
Okay, look at this hyperbola right here. That confirms the rebar spacing.
Wait, did you see that flag? Is that water intrusion near the bottom layer?
Rerunning the scan now.
Here you can observe the foundation anchor system. These visible steel plates are the heads of the 7,000 rock anchors embedded across the chute floor.
The inflow is still trending upward at 0.4 feet per hour. We need to initiate the increase to 20,000 CFs.
Agreed. The atmosphere.
This aerial perspective communicates the engineering achievement and the human contact.
For the emergency reconstruction of the Oroville Dam spillways, completed on schedule and without a single recordable safety.
They were completed that for August 6.
The green option provides the best balance of capacity and cost effectiveness for the spillway.
What about the environmental impact?
The sealant depth here is 3/4 of an inch, full continuity, meets the acceptance standard.
Noted. No structural defects found.
The joint sealants appear fully intact across all transverse joints in this zone.
Confirmed. We're only seeing minor surface abrasion from operational use.
The piezometer data confirms the underdrain system is working exactly as intended.
Yes, the 7-year monitoring shows consistency. The comparison between the 2017 crisis image and the current view communicates the full scope of the American
We are sustaining 35,000 cubic feet per second through all 4 gates.
The elevation is stable. The system is fully reliable now.
How deep do the anchors extend?
They extend deep into the stable bedrock beneath the new slab.
The implicit comparison the video establishes is not between the scale of the two dam systems, but between the response capabilities.
The original 1960s design had isolated drain openings with wide spacing. The rebuilt 2018 system.
This well-lit, inspection quality view communicates the quality of the concrete work that Kiewit executed, and the effect.
Check the reading at the joint.
It's yellow, but within specification. The rest is solid green.
Yes, confirming the release rate is holding steady at 58,000 CFs. Understood on the forecast, we will maintain current operations.
The river level rise is smooth and proportional, currently at 18 feet. The inundation modeling confirms only
the operational system
We're using the chain drag to find delamination. Listen closely for that shift from the sharp metallic ring to a dull, flat sound.
With 4,100 high-hazard dams needing attention, the $1.1 billion
The water surface elevation matches the model exactly. No anomalous turbulence observed. Oroville Dam and its appurtenant structures are in satisfactory condition and performing as designed.
American engineers rebuilt the most dangerous dam in the country into the strongest it has ever been, and made it prove itself under water flow.
Purpose, educational purpose and informational purpose, using advanced AI tool and human creativity. All concept scripting and storytelling are independently developed to ensure originality. Visuals and animation are enhanced using AI technologies such as View 3, Meta AI and Grok AI, while final editing and post-production are completed using CapCut and other professional editing tools. No external creator content has been copied or used any resemblance to real world environment, factories or processes is purely coincidental. All scenes shown in this video are digitally created and do not represent real footage. This content is produced with transparency and follows YouTube monetization guidance. Thank you and subscribe for more real videos. Manufacturing Factory.